Everybody, it's Tyler here at WVROX, checking team number 3504, Girls of Steel, coming out of Pennsylvania. By the way, I'm here with Alex and Ashley, and you got to check out this robot. Really nice intake that they have. We'll talk about, of course, the conveyor and the shooter. Talk about some of the programming that's gone into, and of course, a great aesthetic design. And one thing I really like about this team is just their design process. You'll hear a little bit more about how they pretty much went one and done on the robot, but kept iterating throughout the season. Coming up here on Behind the Bumpers. This video on First Updates Now is made possible by viewers like you and also the following sponsors. If you are a college student or recent graduate looking for an incredible internship, take a look at Stryker. Stryker provides a housing stipend, great pay, and an opportunity to work with state-of-the-art medical technology equipment. Discover why so many First alumni are coming to Stryker for their internship or career at careers.stryker.com. Did you know that over 30% of the student population at Kettering University was in high school robotics? These same students have received a portion of over $7 million from robotics scholarships from Kettering University. See why so many in First choose to go to Kettering University at kettering.edu. So let's start out talking about that ball path through your robot, talking about your intake a little bit, what's gone into it, and a lot of things you mentioned you kind of designed once and it's just worked out for you so far.
Yeah, so going into our build season, because of COVID, we actually weren't able to meet in person for the first 3 weeks. So basically we decided that we were going to CAD a whole robot beforehand because we wouldn't be able to actually prototype, actually come in and build anything. And since we wanted to try and get it as right as possible on the first try, we went for a pretty simple design that we hope would be easy to build and iterate on if we needed to. So I'm going to start with our intake over here. We have a typical over-the-bumper intake. It comes down. Yep, just like that. And can I have a ball? Okay. So our ball our ball comes in just through here. Do you have the other joystick? I'm gonna push it through like that. And then you can see, so over here we have our conveyor system. This is our horizontal conveyor and it just kind of pulls it back into our tower. And something interesting you might notice here is that this is actually super wide, and most teams usually index their balls. And the reason we decided not to do that is just because we wanted to keep our design as simple as possible for all our newer students after coming out of the COVID year. We wanted to build something that would work, even if it doesn't work as well as some other teams. We knew that this would work, so that's what we went with. And you can see that it'll just pull up right into here.
I got to ask you, on your conveyor here, do you have a lot of open space for this? Have you had any issues with cargo popping out or anything like that, or has that worked out pretty well for you?
It's actually worked pretty well for us. As long as our operator is pulling the cargo back and up together, we haven't really had any slippage issues. And real quick, I'm going to have Ashley talk about something that we're doing cool with our intake.
Yeah, so something else is that we actually have this limelight right here. It does not do any green lights or sensing of the hub. It actually just tracks the cargo on the ground, so it can track them. And what we can do with it is automatically go to the right place. Like what we talked about beforehand, we did not have much time to iterate on our design, and also that meant Drive Team didn't have much time to practice. So these were things we had in place and coded before we even got in person, so that Drive Team would have to do much less drive practice to effectively drive. We did run into a few errors, it would get really stuck on trying to detect the cargo versus the launch pads. But we added a circle detector. We haven't used it as much in actual competition because Drive Team actually hasn't gotten much time to get used to it. But that's something else we added. But just the logic of it online to help with making sure drivers have need as little practice as possible.
Can you talk a little about, for using the limelight on it, what kind of feedback are you getting to detect the ball, and then how does that process work with your drive team? Do they have to press a button, or how does that work?
Yeah, so essentially all it is that since limelight can detect different colors, that's all it is. It just detects the color of the cargo, and we can also tell it to detect the certain shape of things so that it doesn't detect the launch pad, and it detects the right color, and they just press a single button and it'll just automatically drive directly to it, so they don't have to worry about that.
How far away is the distance on that? How far away will it actually detect it where you can press that button and it will acquire?
Yeah. Well, normally when we tested it, we mostly wanted to do it around 4 feet away because there's no point in going further because there's other robots in the way. So we mostly just focused on when we're close enough, and then they would just go straight to it.
That's really cool. And, something we've talked to other teams about too is that finding some of the cargo pieces that are kind of tucked behind the hub on the opposite side as well too. Has your team used it to try to find cargo on that side too?
Yeah, it has. And it also doubles as a camera for the drivers actually.
Oh, sure.
So they're also able to look at it while also using it at the same time.
Let's talk about anything else mechanical-wise on your shooter that you want to go through. You got a lot of Colson wheels, both big ones and small ones. Looks like some feeder wheels going in too. So just talk to me about more of that design and how it's worked out for your team.
Yeah. So I'm going to start by saying initially when we first designed this, we were actually a low goal shooter.
Oh, sure.
So we didn't have this back roller here. We just had a piece of polycarb. And that's part of the reason that we had this wide design to begin with, because we were it doesn't matter where the balls are because we're just going to dump it into the lower hub. But after our first competition, we decided that we wanted to try and shoot high. We had 4 days until our next competition because they were back-to-back regionals, and we had a lot of fun actually just going for it. A lot of the code had been pre-done by Ashley and our other programmers, so basically we just prototyped a little bit with doing rollers back here, and those are actually greased with WD-40 on these churros that it's around to help it roll up and gain some more backspin before we get it to these rollers here and just shoot it out. So that's why we have so many wheels, just because we didn't change our whole conveyor design. It's still wide. We just added on top of it because we only had a very limited amount of time. So we actually didn't change that much. We just added this little assembly that you see here.
Okay.
You can see it's very obviously added in, not only by the paint being different, but you can see the two separate plates here. And that was really all it took. We had some we had churros and polycarb back here, so we kind of just took out the polycarb and cut it so that it didn't go out as far. You can see we had holes here. We aren't utilizing them anymore. But it was actually a really fast fix. I cutted these plates in one night, and then we tried to get them cut as soon as possible and just saw if it worked, and it did. So we just ran with it. And nothing else has been changed on here. It was a very fast implementation.
That's what in 4 days, I can't imagine trying to get all that together.
We didn't have time to rebuild the whole thing.
Absolutely. And then this last question, I don't know who wants to take this, but from a shooting style, where's kind of the sweet spot for your team, and then has that been modified really at all based on going to a high hub as well?
So we used to shoot from ram straight into the hub and shoot into the low fender.
Yeah.
Since we changed it, we're more in the middle of the tarmac, not in front of where the balls come out, because that usually messes with our limelight a little bit, but offset from there. And that's managed to work pretty well. We usually shoot from from the tape, but we can do a little bit forward, a little bit backwards. Anywhere within a certain radius from the hub, we've had a pretty okay time shooting at.
A lot of why we were able to do this, other than mechanical doing really well with adding the backspin roller, is that we had a lot of the logic made beforehand, but just didn't have enough time to test it before our first regional. So we had logic of making sure the shooter's at speed, detecting with this limelight over here, making sure we're at the correct distance and angle. And what we did was we were able to shoot from anywhere, so then the drivers also didn't have to adjust to being able to shoot from not at the fender, because of this angle we can't shoot right from the fender. So having all of this automation in place allowed us to easily transfer and also get the drivers used to changing it. And another thing I'd like to talk about are these LED lights. They're sort of flashing, they're getting confused right now, but these LED lights have different signals for the drivers to look at throughout the match. So the bottom 10 lights tell the drivers if the shooter is at the correct RPM using PID control. The middle 10 lights turn green when we're at a good enough accurate range of distance to shoot, and the top 10 tell us if we're at the correct angle. We also are able to automate getting to the correct angle towards the hub, and when all of these three are correct, it'll flash green, and that lets the robot know that it is time to move the vertical conveyor. So they'll just press a single button. This is already shooting, and when all these three parameters are met, the vertical conveyor will move right up, and it'll be able to shoot like that. So it creates as high accuracy as possible, and it just saves drivers a lot of less getting used to.
Well, 3504 Girls of Steel, thanks a lot for taking the time to tell us about your robot course. Good luck here at WV Rocks. Looking forward to your performance here, but looking forward to future seasons as well and what your team can do. So thanks a lot for taking the time.
Thank you.
This video on First Updates Now is made possible by viewers like you and also the following sponsors. Did you know that over 30% of the student population at Kettering University was in high school robotics? These same students have received a portion of over $7 million from robotics scholarships from Kettering University. See why so many in First choose to go to Kettering University at kettering.edu. If you're a college student or recent graduate looking for an incredible internship, take a look at Stryker. Stryker provides a housing stipend, great pay, and an opportunity to work with state-of-the-art medical technology equipment. Discover why so many First alumni are coming to Stryker for their internship or career at careers.stryker.com. Don't forget to like, subscribe, and ring the bell to stay up to date on our new videos. Keep the conversation going and provide your input to our content. Watch our live shows at twitch.tv/firstupdatesnow. Join our Discord at discord.gg/firstupdatesnow and check out Fun FTC on Facebook, Instagram, and Twitter, and First Updates Now on Facebook, Instagram, TikTok, and Twitter.